This is day 11 video. It is for Wednesday, April 8th, and today we're going to talk very specifically about what a permutation is. We've been doing them with the basic counting principle and the other problems, and I haven't gotten a whole lot of questions on those, so maybe we will after this. But a permutation is how many ways we can line things up. And so if I have the numbers 1, 2, and 3, how many different ways can I line them up? Well, I could move everything 1 to the right, and that would give me 3, 2, 1. Continue to do that. 2, 3, 1. And we can change it to 1, 3, 2. Let's see, what else do we have here? 3, 1, 2. And 2, 1, 3. So we've got 1, 2, 3, 4, 5, 6 different possibilities. And that makes sense because I have 1, 2, 3 items. And that would be 3 for the first one, 2 for the second one, and you're left with 1 to put in the third item. And that's going to give me 3 times 2 times 1, which is 6 different ways that I can do that. There's a formula for permutations that I'll show you. It's going to be called the permutations of n items taken r at a time. So this is the total, and this is how many you are using. Now, today we're going to just stick with using the same amount. So n and r will be equal. But let me show you the formula for this. That is n factorial all over n minus r factorial. And this will make perfect sense for you. So if I have a permutation of 6 things taken 4 at a time, that would be evaluated as 6 factorial all over 6 minus 4 factorial, or 6 factorial over 2 factorial. So we can roll this down to 6 times 5 times 4 times 3 times 2 factorial, just like we did before. That's a factorial there. And the 2 factorials will cancel out, leaving me 6 times 5, which is 30. 30 times 4 is 120. And 120 times 3 is going to be 360. Now, there's a way to do this on your calculator, but I don't want you to do that. I'd like you to work it out by hand like this for the day or two. Okay, so what happens if I have a factorial of 5 things taken 5 at a time? Well, that would be 5 factorial divided by 5 minus 5 factorial. And that's going to bring a question here. It's going to be 5 factorial all over 0 factorial. Well, 0 factorial you might think would be 0, but by definition, 0 factorial is equal to 1. So that just becomes 5 factorial. So that's my answer, is 5 factorial. So if I'm using the same number of items that I have available, my formula for a linear permutation a linear permutation where I'm using n is equal to r is simply going to equal n factorial. So let's take a look and see how we can change that and how things alter. So let me erase some of this for us. So right now we're just going to be working with this n factorial. But again, I do want you to be able to evaluate something in this manner and knowing what the formula is. Okay, so let's take the word level. So I've got 1, 2, 3, 4, 5. So that is going to be 5 factorial different ways that I can arrange those letters. And 5 factorial is equal to 120. So there's 120 different ways I can arrange these letters. However, if I were to interchange the e's, would it be distinguishable? So we want to say how many distinguishable ways can I rearrange the letters in level? And that would be 5 factorial, but I have to divide out how many different ways can I arrange these two e's? Well, obviously that's going to be 2 factorial. But I have two L's also. I wrote one as capital, one as small, so they are distinguishable. Pretend they're both the same. And there are two of those, so I would have to divide that by 2 factorial. If I had 3 e's in a word, one of these would be a 3 factorial. So we're going to take our 120 and divide it by 2 factorial, which is 2, times 2, which is 4, and that's now going to bring it down to 30. So this is a linear permutation with repetitions. And you have to divide out how many different ways we can arrange those together. So it's not too hard, just want to make sure. Another way that could mess this problem up, let's just say we have a penny and a dime. And I'd like to know how many different ways can I arrange a penny and a dime? Well, obviously, there's the penny, there's a dime, there's a dime, there's a penny, and there's two of them, so it's 2 factorial. There's only 2 ways I can do that. But remember, a penny and a dime both have a heads and a tails. So this could be penny's head, dime's head. What about penny tail? Dime head. And I could then do penny tail and dime tail. So basically what we're going to have is the 2 factorial for the penny and the dime. And then I'm going to multiply that how many different ways the penny can come up. And that's times 2. And then I'm going to multiply by how many different ways the dime can come up. And that's going to be 2. So my 2 factorial is 2 times 2 times 2. Now I've gone up to a total of 8 different ways instead of 2 that those penny and dime can be arranged if I take into account the heads and the tails. And the problem will have to tell you if it does or doesn't. Okay, now let's take a look and see if I have those same 3 numbers, the 1, the 2, and the 3. And we already determined that that's going to be 3 factorial different ways I can arrange those, or 6 total different ways. And I think I wrote them all out before. That's a linear permutation in a straight line. If I have a circular permutation, so it doesn't have a beginning or an end, I can put the 1 here, the 2 here, and the 3 here. If I were to change that to the 3 here, the 1 here, and the 2 there, is that a different permutation? Well, to the right of 2 is 1, to the left of 2 is 3. Over here, to the right of 2 is 1, to the left of 2 is 3. So that doesn't count. If I did the 3 here, the 1 here, and the 2 here, well, that's a different permutation, because now to the right of 2, I have 3. I used to have 1. So that's different. And as it turns out, these are the only 2 different permutations of the numbers 1, 2, and 3, or any 3 objects in a circular permutation. And because of that circular permutation, because we have no beginning or end, we're going to go down to n minus 1 factorial. And there's all kinds of other little things that we're going to work on this in the next couple days, but I think that's probably good enough for now. Please don't hesitate to ask me any questions. I'll do videos for solutions if you want me to. Check the answers that I'm posting. If you're getting them, that's great. If not, don't hesitate to ask. All right, guys, have a great day. Thank you.